Hey guys and gals, we're going to be looking at proportions, and proportions should be a review. This is something you probably covered maybe fifth grade, sixth grade, perhaps Miss Morris covered it with you last year in algebra. But proportions is something that typically seventh grade students deal with, and we're going to go through it pretty quickly because this entire unit, or excuse me, entire chapter, chapter 6, deals directly with proportions. So today, this video is just simply how do proportions work, how do we solve them, we'll go from there. Real quick, what is a proportion? So let's deal with the grammatical issue first. What is a proportion? That's a question. A proportion is simply an equation that relates how two ratios are equivalent. So notice, I've got a ratio here. And by the way, a ratio is just another way that we can write a fraction or relate two objects together, two numbers. So in this case, 2/3 is equivalent to 6/9. And I know this by a couple of ways. One, I could multiply both 2 and 3 by 3, and that would get me 6/9. I could also take 6/9 and divide them by 3 and get back to 2/3. So in that way, I know that they're equivalent. Another way that I know 2/3 is equivalent to 6/9, or for any set of ratios that form a proportion, is that their cross products are equal. So in other words, if I take the numerator on one side and multiply it by the denominator of the other, and then do the same for the other numerator and denominator, we should get numbers that are the same. So in this case, if I take 2 times 9, well, that's 18. And if I take 3 times 6, that's also 18. So I know that 2/3 and 6/9 do indeed form a proportion. If I had another set of ratios, for example, if I had, say, 1/7 and, I don't know, 2/10, right, I could test that to see, well, are these a proportion? Do these ratios form a proportion or not? And again, I could simply do cross products. So I could multiply 1 by 10, 2 by 7, and just see, do they equal? If they are, wonderful, they're proportional. If they aren't, okay, well then they're not. 1 times 10 is, of course, 10. 2 times 7 is 14. And in this case, it's very obvious we do not have a proportion. 10 is not equal to 14. So this is one way we can check if we do have two ratios and we want to know, do they form a proportion? We can use cross products and very quickly see what we need. A lot of times today, we're going to be looking at ratios and we want them to form a proportion. So we might be solving things wanting these two sides to be equal. For example, in this case, we're going to solve this proportion so that way X does indeed create a proportional situation as opposed to one that's not. So here's what we're going to do. We're going to do cross products. So we'll do 3 multiplied by 75, and then we'll do 5 multiplied by X, and we'll see what we get. Let's see, 3 times 75, if I'm not mistaken, is 225. But let me double check myself because for some reason I feel like I'm wrong. I don't think I am, but let me double check. Yeah, 225. Never second guess yourself. There we are. And then on the other side, of course, we get 5x. From here, we'll divide both sides by 5. And in this case, we will get 45. Excellent. So this number, x, if we want it to be a proportion, these two ratios, would have to be 45. And in this case, I could multiply 3 by 15 to get to 45. I could also multiply by 5 by 15 and get to 75. So that's how we would solve that. Let's try one that's not just a proportion. Let's make it a little bit more algebraic. So what I'm going to do is do my cross products first. So let's write that down. So 2 multiplied by 3x subtract 5. And then on the other side, 4 multiplied by a negative 13. Now, I know what some of you would be tempted to do. Some of you would be tempted to go ahead and distribute that 2, and you're welcome to do that. But one thing I notice when I do this is that 2 will go into 4 evenly. So one thing I could have done was left the 2 behind, so to speak. In this case, I'll just go ahead and divide both sides by 2. And notice I'd get my 3x subtract 5 here. And over here, if I just multiplied the 4 by the negative 13, notice leaving that 2 behind is actually going to make my life easier. These numbers don't get larger, and 2 will go into 4 evenly. So 3x subtract 5. In this case, we would get negative 26. There's no sense in multiplying that 2 through. I mean, you could, and that would work. But in this case, I'm just trying to keep my numbers small. So from here, let's go ahead and add the 5 to both sides. So that's 3x equals, and notice that's adding 5 to a negative 26. Be careful, folks. So that's negative 21. And then in this case, we'll divide by 3. So x is a negative 7. So if I plug negative 7 in for our value here, we could get a value that would make both sides equal, in this case, a proportion. All right. Let's try something from nature. All right. I always like problems like this because they're kind of fun. They make things seem kind of odd. Let's look. Suppose the average 8th grader is about 5 foot tall, and I'm just making a guess here. I have no idea how tall the average 8th grader is, but let's assume. Average 8th grader is 5 foot tall. I did look this information up. The average adult African elephant stands about 10 foot tall. All right, so keep that in mind. If the ear of the elephant is about 4 feet long, so if we were actually to draw out an elephant to scale relative to its height would be 10 feet and its ear length would be 4 feet. So that's kind of crazy. How long would an 8th grader's ear be if the two were proportional? When we're setting up proportions in the real world, we want like items either across from each other in our proportion. So for example, if I was to compare the 8th grader's height on the left, then I would want the elephant's height on the right. So that's one way to do it. So we want like items across from each other. The other way to set up a proportion is to have like items top to bottom from each other. So again, if I had the 8th grader's height on top here on the left, then I would want the elephant's height down here at the bottom on the left. So I'm going to set it up both ways, just so that you can see there are multiple ways to set this up. So I'm going to put the 8th grader's height up here, so 5 feet, and I'm going to keep the 5 feet there just so we know what it is. And then the elephant was 10 foot, so I'm going to put it across. All right, and that is a perfectly valid way of doing it. Another way, let's put the 8th grader on top here, because again, if we put the elephant on top, poor 8th grader would get squished. There we are, so 5 feet there, and we could put the 10 feet for the elephant here. Okay, either way would be acceptable. Now remember, we want like items. So if we're talking about the elephant's ear, all right, well, this was the elephant's height, so the elephant's ear would need to go below. Elephant with elephant. So 4 foot. All right, let's look over here. Again, if I've got elephant here, then I would want elephant here. So elephant's ear height is 4 feet. Again, I looked this up. I couldn't believe it, but 4 feet. It's amazing. What we want to know is, how long would an 8th grader's ear need to be? So again, 8th grader with 8th grader, or 8th grader with 8th grader. How long would it have to be in order for this to work? So take a look. I can do cross products pretty quickly here, and I'm going to use this one just because I've got a little more space and I write big. So 5 times 4, 10 times x. So that gives me 20 equals 10x. Of course, we'll divide by 10, and that gives us 2, or in other words, 2 feet. So here's our question. Are 8th graders proportional to elephants? If you're talking about height and ear length, no. The typical person, I would guess, maybe an ear length of, I don't know, 2 to 3 inches, something like that, not 2 feet. So big fat, no, we are not proportional with elephants in that way. We might be proportional in other ways, but certainly not when we compare heights to ears. I mean, goodness gracious, you'd have a poor person. I mean, think about it. If the average 8th grader is 5 foot tall and your ear had to be 2 foot, I mean, goodness gracious, your ears would be like this. Again, that would make you proportional with an elephant, but goodness, certainly not proportional to the way we are now. So anyway, I like examples like that. Those are kind of fun. All right, well, let's talk about some other examples. Let's get into the nitty gritty here with the math. So we'll start with stuff that's really simple and straightforward. We'll go with something that's a little bit more and then we'll get into something that's, oh my gosh, what is that? So here we go. Let's start with the basic stuff. So again, cross products, we'll take 8 times x and 3 times 5. So that'll give me 8x and 15. And then all we have to do is divide. So in this case, if I take 15 and divide it by 8, oh goodness gracious. If we wanted to write it as a decimal, which I know most of you would, that's roughly 1.875. Yeah. If we wanted to write that as a fraction, which is more my cup of tea, I would have written it as 1 7/8. Either answer would be acceptable, though if you are typing this into a Google form, I would recommend the decimal version. Google really does not like fractions, so heads up. All right, let's try another one. This time we've got more of an algebraic setup here, multiple variables as opposed to just the one. So let's work through it. So again, we'll multiply cross, so here and here. So let's write it out. So I've got 6 parentheses, b added to 1, close parentheses, is equal to 5, open parentheses, b subtract 1, close parentheses. Now notice in this case, 5 and 6 don't divide very well. So I'm going to go ahead and send those through. So we'll distribute in both cases. So 6b added to 6 is equal to 5b subtract 5. And again, the only reason I do this is because they don't divide well. If they divided well, then I'd go ahead and do that. In this case, we'll keep going. First thing I'm going to do is subtract 5b on both sides. So that's 1b added to 6 is equal to -5. And that's a 6, not a b. Make sure I write it so that you can read it. There we go. And then last but not least, we'll subtract 6 on both sides. So b is equal to a negative 11. So cool. If I plug a negative 11 here in both cases, we'll get a proportion that works. Right. Last example. Again, cross multiply. So we'll multiply in this direction, multiply in this direction. Let's see what we get. On this side, we'll get 3x subtract 1 and x added to 2 here, multiplied. And we'll talk about that in a minute. And then over here, we'll get 2 multiplied by negative 2. Now, I know last year with algebra, you might have been rushed. And let's talk about how you multiply polynomials. That's what we call these things, polynomials. You might have remembered the acronym FOIL, which stands for first, outer, inner, last. So here's what we do. When we multiply these, I have to multiply this term by all the terms over here. And I have to multiply this term by all the terms over here. So what we do is FOIL, that's the acronym, first. So the first thing I'm gonna do is multiply the first terms together. So 3x times x is 3x squared. I'm gonna multiply the outer terms, so the 3x by the 2. So notice I multiplied this term by both of the terms here. So 3x times 2 is 6x. All right, inner. So notice I'm going to multiply this term now by both, and that is a negative 1. So negative 1 times x is a negative 1x, or just negative x. And then last, so I'm going to multiply this second term by the second term of the other polynomial. Negative 1 times 2 is negative 2, so I'm going to write it as adding a negative 2. We'll clean that up in a second. On the other side, 2 times negative 2 is simply negative 4. Isn't that nice? Notice I've got this 3x squared. Nothing else looks like that, so I'm going to write it down. I've got a 6x and a negative x. Those are like terms, so I can combine those. 6 added to a negative 1 is 5. And then last but certainly not least is this negative 2. Notice negative 2 has nothing really to work with here, so we'll rewrite it, and then, of course, negative 4. Yikes, we've ended up with something that is quadratic. That is not a lot of fun. So there are multiple ways to solve quadratic situations. First thing I'm going to do is make it so that this is equal to 0. So I'm going to go ahead and add the 4 over here. So let's rewrite it. So 3x squared added to 5x added to, if I add 4 to negative 2, that's a positive 2, and that equals 0. So now we need to solve this quadratic situation. And there are a couple of ways to do it. One way is the quadratic formula. So I'm going to write that down. You by no means need to memorize it, but I am going to write it down in case you forgot it from last year. That's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Isn't that fun? That's one way to do it, where a represents the 3, the b represents the 5, and the c represents 2. So you can plug all those numbers in and see what possibilities you could get for x. That's one option. Another option that I'm going to try first, just because I think it's going to be a little easier on us, is to try and factor this. So in other words, we're going to do FOIL kind of in reverse. So instead of taking this and coming to that, I'm going to take this and see if I can work it into something else. All right, so let's see here. So the first thing I'm going to do is see how can I multiply two numbers together to get 3x squared. Well, 3x and x sure do seem like a good option, so I'm going to write those down. So 3x and x. All right, the next thing I'm going to try and figure out is how can I get a 2? Well, a 2 can be achieved by multiplication, really only one way, at least with whole numbers. We can multiply a 2 and a 1. So that's what I'm going to try. I'm going to try a 2 and a 1, and let's see what happens. I'm going to try to take this and go back to the original just to make certain that this is the correct factorization. So 3x times x is 3x squared, so that looks like it works. 2 times 1 is 2, so that's how that works. I need to multiply the inner terms and the outer terms, because notice I did the firsts and I did the lasts. Okay, the firsts and the lasts, I need to do the inner and the outer. So the inner two terms are 2 and x, so 2 times x is 2x. Hold on to that. 3x times 1, well, that's 3x. And if I had 2x and 3x, sure enough, that's 5x. That's a good factorization. Now that we're here, we have, remember, when you're solving quadratics, you have two potential answers. This could have equaled to 0, or this could equal 0. So I'm going to solve both. So 3x plus 2 could equal 0, or x added to 1 could equal 0. All right. So to solve this, I'm going to subtract 2 on each side. So 3x is equal to negative 2, and then we'll divide by 3. So one version of x is negative 2/3. Excellent. So that's one potential answer. The other answer, we'd have to solve this equation, because remember, either of these could equal 0. We're not sure which one. So we'll subtract 1 on each side, so x could equal negative 1. So there are my two answers. So for this proportion, or to be true, x could have two potential answers. X could equal a negative 2/3, and if I plug negative 2/3 in for both of these x positions, these two fun ratios would be equal. Or I could plug in a negative 1 to both of these positions, and that would also work. You shouldn't see too many of the quadratic versions. If you do, again, we can talk about it when we get together as a group. Otherwise, have fun with the proportions. They're very, very basic, very, very simple. Should be an easy way to get a good grade. Have any questions? Bring them with you to class. Have a good day, folks.